When we first started talking about our trig functions, we were focusing on right triangles and using SOHCAHTOA. And we did some applied problems. I'm just going to make something up. Maybe we were trying to figure out how tall a building was. So we stood 100 feet away from it. And we said this was, I don't know, a 60-degree angle. And we were trying to find the height. And then we used our SOHCAHTOA and we said, oh, look, the tangent of 60 is opposite over adjacent. And then to solve that for x, we would just multiply by 100. And then we would plug that into our calculator and get the answer. Okay, we did that. Now, this calculator part, that's what I want to talk about. If you plug this into your calculator, it's going to give you a number. Now, I'm not going to multiply it by 100 at the moment. I'm just going to do tangent of 60 and see what the calculator says. And the calculator says 1.732, and it keeps on going. And we do rely on our calculators for finding lots of those. But what I want to focus on is, can we do better? Can we get an exact value? And the answer is yes, we often can find an exact value of the tangent of 60 degrees. We can't do it for every angle measure, but for some we can. So that's what we're going to be working towards. First, I want us to think about something called the unit circle. So let's say we have a circle. It's centered at the origin and it has a radius of 1. Okay, so it goes through these points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So we want to take a look at this point. So I'm just going to, this is some angle theta. And when we go theta up, we have this point here. This point we call x and y. And if we were to make a triangle out of this, so from that, I'm just going to drop that side down and that side over. Do you see I have a nice little triangle there? I can do it in pink if you'd rather. You can see it a little bit better. Okay, so there and there. This distance is x and this distance is y because that point is x, y right there. Also, I want you to notice that if you wanted to find the sine of theta is opposite over hypotenuse, so that's y over 1. Cosine of theta is going to be adjacent over hypotenuse, which is x over 1. And tangent of theta is going to be opposite over adjacent, which is y over x. Now, a couple of those things we don't actually need. We don't need the over 1 part, so we'll just get rid of those. And this is a really cool thing about the unit circle is that if you want to find any point, for any point on here, if you take the cosine of the angle, that gives you the x coordinate. And if you take the sine of the angle, that gives you the y coordinate, which is pretty cool. So even if you were over here, if you had this angle, the sine of that angle would give you this y coordinate down here. And the cosine of this angle would give you this x coordinate. Okay, so we're going to kind of play around with that a little bit. To do that, we need to remember our special right triangles. I told you that you needed to know these. You need to know them really well because we're going to use them all the time. So remember, for a 45, 45, 90 triangle, the sides are 1, 1, root 2. When we did them before, we did like x, x, and x root 2. But for this, we just need the simplest version. So 1, 1, 1, root 2. And then our other special right triangle is the 30, 60, 90. The sides are 1, 2, and root 3. 1 is the smallest, so it goes across from the smallest angle. 2 is the biggest number, so it goes across from the biggest angle, or the hypotenuse. And then across from the 60 is the root 3. Okay, so if you need to reference those, they are there. So to find the exact value of a trig function, we're going to draw it in standard position. We're going to find the reference angle. We're going to draw the right triangle using the x-axis. That's important. A lot of times people mess up and use the y-axis. So always with the x-axis. We're going to create a special right triangle, fill in with negatives if we need it, and then we're going to use SOHCAHTOA. I know those sound like a lot of steps, but we'll get there. It's fine. So first thing we're going to do is we're going to draw this thing. Okay. So 120, so here's our initial side, and 120 is over here somewhere. Looks good, right there. Okay. So this is 120 degrees. We need to find this reference angle over here. So to find that reference angle, it's going to be 180 minus 120, which is 60 degrees. So this has a 60-degree reference angle here. I'm going to write that in. All right, so now we are going to actually draw the triangle with that reference angle. So I'm going to draw here and here, and we're going to focus in on that triangle. We're going to fill in the sides because this is now a 30, 60, 90 triangle. So this is where we need to remember our sides. So 1, 2, and root 3. The 1 goes across from the 30-degree angle. The 2 is the hypotenuse. And then this is root 3. Now, this part says use negatives as needed. I want you to think about this point. To get to that point, we are going left 1 and up root 3. So this is going to be a negative 1 because we're left 1 and up root 3. Okay. All right, so the last step is we want to find the sine of 120. So we're going to look at this triangle that we just drew, and sine is opposite over hypotenuse. So the opposite side is root 3, and the hypotenuse is 2. So the sine of 120 is root 3 over 2. Now, if you put that into your calculator, and remember you can use that Decimo Scientific calculator if you left yours somewhere at school. Sine of 120, your calculator is going to say 0.866. Okay, calculator says 0.866. In your calculator, if you take the square root of 3 and then divide that by 2, it is going to tell you 0.866. So this is the exact answer for what your calculator. We don't want this anymore. We want the exact value. I'm going to show you a bunch of different examples going through the same process, but these 5 steps are what we're going to be working on.